Hello, Professor. This is our team members. First, I'm going to briefly remind you some background information about our project. So our system aims to help the government to monitor and manage disasters after an earthquake. So there will be nuclear leak from a nuclear power plant in the city after an earthquake, and the city has sensors to measure the radiation values at different locations. So our data set is those measurements at different time and different location. Next, Han will show you our data sets and how we processed it.
To begin with, here is the dataset we have. We decide to put the project resources in the public directory that can easily be accessed, because all the data are created for the West challenge. The shapefiles of the city map are provided. We converted the shapefile into a single GeoJSON file, which is more suitable for the leaflet and D3. In terms of sensor data, we have sensor readings from both static and mobile sensors with 5-second intervals. Static sensors come with sensor readings and a geological location in different files. It can easily be combined with static sensors reading by IDs. Differently, each record of mobile sensors consists of a reading and a location. Sensor readings are of the same unit. After analyzing the raw sensors readings, we found that static sensors are more stable and clean than mobile sensors. Therefore, we take the first day's data as a benchmark and model the sensor readings as normal distribution. This model is used to adjust all the reading of the mobile sensors, and we store the processed data also in the public directory of our project. On the top left corner is our map view. It consists of several leaflet layers. The city map is plotted with white dashed lines indicating different counties. Markers of the nuclear power plant and hospitals are also added by default. When the system is ready, we can switch on different layers from the button on the top left corner. Firstly, we can turn off the current layer and turn on the contour view. In this view, we draw the heat map from the center readings. For debugging here, we also plot the square graded view of the data used for generating this heat map. Sensor readings are currently encoded as an interpolation between green and red. The higher value is mapped to red. Next, we can switch off this heat map and enable the density map. Under this view, we know the number of unique sensors in a hexagon region for a specific time period. As we can see for now, it shows the center of the city contains much more mobile sensors, and this location might be the downtown of the city. Moreover, it shows that some regions do not have sensor readings, and these locations are the blind spots of our city's monitor system. We also support changing the grid size of this density map. Additionally, to understand the moving pattern of mobile sensors, we are developing the flow view. It can be used with the density map. The flow view helps visualize the mobile sensors movement from a selected region to other regions within a time period. The curved lines drawn between two hexagons show the unique mobile sensors flowing between them, and the white to blue interpolated line color encodes the number of sensors. Okay, that's all for our map view. Next, we will have one to tell you more about our sensors table view.
The table view is showing us some detailed numerical information. So we have 8 columns: the sensor ID, reading, sensor type, reliability, running mean, running median, and 2 graphs. The first graph is a running line chart that shows different values at different time in a time period. And the box chart is showing us some statistics in that time period. For example, the minimum, the maximum, the first and the third quarter, and the median values. When we click each column, it can be sorted. For example, we can click center ID or readings. And when we click again, it will be sorted in the other direction. Right now, the data in this table is hard-coded, but for the map view and for our timeline view, they already connect data to our data sets. So next, Zhen is going to talk about the timeline view.
For the timeline view, we have implemented the line chart, the range slider, and the brush layer. The range slider controls which part of the data is showing on the line chart. It doesn't have linking to other views, but it moves and scales the line chart. We implement this to show user the detail of the lines when demanded and help them to select the accurate time. The brush layer chooses the actual time point or time interval and send them to other views so they can change their data accordingly. Our implementation requires event handling to communicate between views. We think it's too complicated for this update, so we will implement it in next stage. The basic infrastructure is already here though. This alert is called by the app when the event fires. The line chart shows all the data for these two mobile sensors from our data store. We show all the data as an example of the worst case scenario. So far, showing all data for all sensors still have performance issue and is a bit crowded. We will optimize the render in next stage. Click on the legend or the line. We'll select the sensor and also fire an event to other views. Multi-selection needs to be implemented in next stage. That's all we have implemented now, and Guozhen will talk about what we will do in next stage.
As you have seen, we already have some user interaction in each view. In the next step, we will have more interaction between these three views. For example, if we select a sensor in one view, in the other two views, we will highlight that sensor. Please note that our system have two modes. One is dynamic mode and the other is static mode. In the dynamic mode, our system shows the data coming into our system as a real-time system. While in the static mode, we can select a time point in the timeline view and show the map and the sensor reading at that time step. In the next step, we will be able to brush the timeline to show the animation of that time period. In the animation, we will show the change of map and the sensor reading in that time interval. That's all about our system design now. Thanks for watching.